Yes.
Okay. So, very first thing we're going to look at, like today we're going to talk about 45, 45, 90 triangles. It's not very long notes, but again, we're just like going over triangles still from the last part. So this is Unit 7B. This is the second half of Unit 7. Okay. So we just took over a test over the first half. You're going to take a test strictly over the second half. You're still going to have to know how to simplify radicals and do some of those other properties, but they're not going to be as prevalent on this test. All right, so the first thing, if you cut this square in half to draw two triangles, what can we definitively say about those triangles? So I want you to take a second, cut the square in half, and I want you to just list off to the side here, what do you know for a fact about those two triangles? For those of you at home, you're doing the same thing. So pause the video, fast forward the video, that's fine. But take your time to write and list down what you definitively know about those triangles.
It's not here.
Either one. Yep.
I knew I talked to you at some point today. But I didn't put it here.
I did get a message. But-
I
Uh-huh.
told her to send you one.
But it was, yeah. But it wasn't like, yeah. I'll talk to you about it. Okay, what can we say? Lucy, what'd you write down?
They're both right triangles.
They're both right triangles. Very good. You know that why?
Because the squares are equal.
So a square, it's equal angles, right? So they're both right triangles. That's a good one. That's a good one to start with too. So there's a right angle down here. Now remember, there's a right angle here and here as well, right? Okay, so what else can we say? Me, what else did you write?
I said they're vertical.
Vertical?
Yeah.
Okay. Oh, like on top of each other?
Yeah.
Okay.
I
Yep.
don't know if those are vertical.
Mia, do you think that these would be congruent triangles or no?
Yeah.
I agree, right? It should be. You're cutting a square. Everything about a square is exactly the same, so they're congruent triangles. Okay. How about something else? So we know this is 90 degrees. What about like the other angles? What about the side lengths? Are there anything about those?
The angles are 45.
The other two are 45 and 45, right? How do you know that?
Because triangles add up to 180.
They add up to 180, and not only that, but it comes from a square, right? If this was originally 90 and I cut it in half, what do you have now? 45 is half of 90, right? So so it has two 45-degree angles. Okay? And this one's pretty important for today, the last one I'm going to ask for. There's probably a bunch more stuff, but anything about the side lengths of this triangle?
They're all like similar. Or they're the same.
What do you mean? Which ones? Because there are three, right? You have the hypotenuse and a leg and a leg.
They're all the same.
All three?
Except the hypotenuse is one
The
side.
legs are. Very good. The legs are exactly the same, right? It came from a square, correct? The properties of a square tell you that every single side length is the same. So if I have a 45, 45, 90 triangle, okay, both of the legs are the exact same size. And that happens every single time with these triangles. Both legs are exact same size. Okay, and we could write that like this, right? That they're congruent. Remember the congruent line? So both legs are the same size. So that's good to know, because if you don't know some of the properties of a 45, 45, 90 triangle, you now know I can just draw a square, cut it in half, and that helps me to remember some of the properties, right? Okay, so the fill in the blanks here. A 45, 45, 90 triangle is a right triangle with two congruent angle measures of 45 degrees. So it has two angles that are exactly the same. in a 45, 45, 90 triangle, the legs are congruent, which is what we just said. Okay, so all properties are extremely important. Okay, so we are going to go through this chart looking at 45, 45, 90 triangles, and we're going to determine the length of each of the legs, okay? Based on that information right up there above, what we already know. So in example 1, in this first triangle, you have, this is 8, then you have this missing value of y, and then you have that missing value of x. So which one are the legs? 8 and y, right? 8 and y. 8 and y are the legs. What's x? The hypotenuse, right? It's the hypotenuse. Okay, well what do we just determine about a 45, 45, 90?
Each legs are the same.
Each leg is the same, so what is y?
8.
8. So y is 8. And I just wrote there as a reminder that the legs are congruent. So you shouldn't have to show any work for that, right? That's a pretty easy problem. You don't have to do Pythagorean theorem for the leg. You do, however, have to do it to find the hypotenuse, okay? At least until you really get to know them. So that's what we're going to do. For the hypotenuse, to find x, we're going to do the leg, the other leg, and solve it for the hypotenuse. So a squared plus b squared equals c squared. Okay, this makes it 64, 64. This is 128. Okay, and at this point, we would take the square root, and we're probably going to get a decimal, which is fine, but in this case, we want to leave it in a radical form because I want you to recognize a pattern, okay? So what we're going to do is we're going to simplify this radical. What's the biggest perfect square that goes into 128? You could use your calculator.
Would be
8 and 4 goes into it, but bigger. 11's not a perfect square. It's okay. Remember, the perfect squares are 4, 9, 16, 25, 36, 49.
16 and 4.
16 and 4 go into it. What else? Bigger.
Oh, we're having 11 times 11.
So that would be what? 121. That's very close, but it's not exact, right?
12,
Yeah.
12,
Bigger,
1,
bigger. Let me give you a hint. What number did we just add together?
Oh, 64 and 2.
64 and 2, right? 64 twice goes into 128. Mind blown, right? Okay, so this breaks down into radical 64 and radical 2. We just have x left over because we already took the square root. Which breaks down to what? What's 64 break down to? What's the square root of 64? 8, because that's what we started with, right? Man, we are working backwards here. So this is 8 radical 2. Kind of working backwards, all right? So what was the length of the hypotenuse? Right there, it's 8 radical 2.
So that's the answer.
That's it. Yeah, because we did Pythagorean theorem to find the hypotenuse. Of course. Okay, how about the length of each leg in this first one, or in the next one? 4, right? One leg is 4, other leg is 4. Okay, got to do the same thing. We got to find the hypotenuse here. We don't know it. There's no easy way to do it. So if both legs are 4, 4 squared plus 4 squared.
16,
Okay, so 16 plus 16
32.
squared, 32. Is that squared? Okay, we're going to take the square roots.
16 and 2.
How'd you know that?
Because we added 16.
Because we added 16 twice right before that, right? Weird. Huh, okay. Radical 16, radical 2. And this simplifies to the length of the hypotenuse. Square root of 16 is 4. Radical 2 does not simplify. There's your hypotenuse. 4 radical 2. What were the legs again?
4.
Okay. What was the length of the hypotenuse in the first one?
8.
8 radical 2. What were the legs there?
8.
Okay.
Oh, I see the
Okay. Just checking.
Is that like that for everyone?
Just checking. Alright, let's try one more here. Alright. What's the legs on this one?
6.
So n equals 6. Okay. Alright, so 6 squared plus 6 squared equals x squared, right? Because that's the hypotenuse is x, I think, right? Oh no, I'm sorry, it's m. They changed the letter on us here. Okay, 36 plus 36 equals m squared. 36 plus 36 is 72. Take the square roots. 36 and 2 go into it. Square root of 36 is 6. So the radical 36 simplifies to 6. There's my hypotenuse. What were our legs again on that one?
6.
What's our hypotenuse? 6 radical 2, right?
Are all of them like that?
Yes.
Or all-
45, 45, 90.
Yes. So there are multiple right triangles, okay? It's a right triangle if it's got a 90-degree angle. Oh, that's not very good. But sometimes that 90-degree angle doesn't mean a whole lot for these. Like the next one we're going to work on tomorrow is a 30, 60, 90. Or, which actually probably looks more like this, okay? Like a little sharper of a point. But really, as you start to move this top down along, it changes these two angles, right? And they could end up as like 31 and 59, or what, 42 and 48, right? Sure. Okay. So they could end up as anything. But what we're focusing on today is what's called a special right triangle. It's special because it's one that we can always determine the length of it very quickly, right? 45, 45, 90. It's special because we already know the legs are always the exact same. That's not the case in other right triangles. But in this type of right triangle it is, okay? So the benefit of that is, like when you have an assessment or a test, or you're looking for triangles or like the sides or whatever, if you recognize it's a 45, 45, 90 triangle, you can use the properties of it that we already know to speed up the time that it takes you to solve it, right? You can use those properties. So the last one here, notice that now it's a little bit different. They give us the hypotenuse, right? The hypotenuse is 7. Oops. 7. But it does not give us the legs. Okay, but do we know anything about those legs without the numbers? They are the same, right? So we can still use Pythagorean theorem and work our way backwards, okay? So instead of saying x and y, we're just going to say x and x. So we're going to say it's x squared plus x squared equals 7 squared. So how many x squareds do I have right there? 2, so this becomes 2x squared equals 49. Okay, then I'm going to divide by 2. X squared equals 49 over 2. Okay, you guys with me so far? Alright, I'm going to take the square root of both sides. Okay, now the square root of a fraction, if I have the property of a big one, you can split it up and say this is radical 49 over radical 2. Okay, you're allowed to split that up. That's a property of radicals. Which makes it nice for some of it, because what is the square root of 49? 7. So this would be 7 over radical 2. Now that would typically be an answer except for one fatal mistake. What is that? It's unallowed. The math police will handcuff you and take you to jail.
You can't square out a perfect number.
Huh?
You can't square a
No, you can do that.
Isn't it?
You're not allowed to have a radical in the denominator. So this is where we have to rationalize. Do you remember back in like the first week, I think we rationalized denominators? So how do we do that? Multiply by what was on the bottom. Okay, so this becomes 7 radical 2 over radical 2 times radical 2 becomes radical 4. And what's the square root of 4? 2. So there are our legs. So you can see when they give us our hypotenuse, but they don't give us the legs, boy, is that a pain in the butt, right? And it's going to be messy. Yes?
Why, instead of like making it a fraction, why wouldn't you just do 49 divided by 2? And make it 7.
And you could do a decimal.
Yeah, could you do that?
You could, but then it'd be the square root of a decimal. So it's not going to be an exact number. Yeah. So you absolutely could. So if somebody said, give me the approximate answer, if I said, give me the approximate answer, you could turn it into a decimal and that'd be fine. Okay? But in most cases, when we're working with these triangles, they're going to want you to leave it in radical form. So that's why it turns out a little bit messy. So the answer for the legs would be 7 radical 2 over 2. Now I'll give you hints. It would be the same pattern if you did it for all of these. Like if I had 8 as the hypotenuse, it would end up being 8 radical 2 over 2. But then that one would simplify, right? It would simplify to 4 radical 2. Okay, so that happens a lot. All right, so there are a lot of patterns with these special right triangles. It just all depends on like how much time you want to take to figure out those patterns and to learn and memorize them, right? Okay, so moving on here, it says in a 45, 45, 90 triangle, the length of the hypotenuse is the length of the leg. So this is what we just did. So if you know the length of the leg, what do you multiply it by to get the hypotenuse?
2.
Radical 2. Radical 2. So it's leg times radical 2 equals hypotenuse. Okay? You can use that same philosophy too to work backwards. Let's say they give you the hypotenuse. Alright? But they don't give you the leg. Well, you could work backwards and solve for the leg that way too. You would not have to use Pythagorean theorem. So there are multiple ways you can solve it. Alright, so here's what I want you to do. I want you to try these practice problems. There are 4 of them. The answers are at the bottom, but I don't want you to look until you've actually gone through it, okay? So try these 4 first, and then you can start your exit ticket for the day. Alright, and then on Monday, this is what, Group B?
Yeah.
So on Tuesday, you'll get your test back. You'll get your test back. We'll look at some corrections and we'll go through that.